You're watching The Morning Show from your local news leader.
We are in our kitchen turned chemistry lab this morning with Mr. Jesse Miller from the University of Illinois. Good morning.
Good morning to you.
All right, so hot outside.
It is indeed. And I know you guys have been talking a little bit about heat index, or at least you give the heat index in your weather report and stuff like that. And so I thought maybe I'd talk about what is the heat index.
Right.
Exactly. You know, it's a lot like wind chill. It's been around since about the 70s when National Weather Service adopted it as a thing that we use to describe how the weather feels as opposed to how it actually is. And that sounds kind of weird, and you know, it is kind of weird. But
it's helpful because that's what we want to know.
It's helpful in this regard because, okay, the actual temperature is whatever the actual temperature is. And there's two things that go into the heat index: temperature and relative humidity. Okay, and I'll just talk real quickly about what relative humidity is. Relative humidity, when you say relative humidity is 80%, that doesn't mean that 80% of the air is water. That would be ridiculous. What it means is that however much water the air can hold at that temperature, it's saturated to 80%. So it still has 20% it could go. So a relative humidity of 100% means the air is completely saturated. You couldn't put more water in it if you tried. Okay. So 80%. There's room for some, 50%, there's room for, it's only half of as much, okay?
Sure.
Now, why is that important? Well, your skin, okay, your body, we cool ourselves off by using our skin, the largest organ in the body. And we perspire, and as we perspire, that water evaporates, and as it evaporates, it cools us off, okay? And we can see that I have some alcohol here. And I have a thermometer. And, if I wave this thermometer around, okay, it doesn't change the temperature. It's still at about 73 in here, 74, something like that. Okay, you can see that. Now, if I dip it in some alcohol, which is really volatile, it evaporates really quickly, and then I wave this around, okay, now we can see that the temperature is dropping rapidly, 62, 61. Okay, so that as the alcohol evaporates, it takes heat away from its surroundings and cools it off. So that's how we cool ourselves down. Okay, so how does this have to do with relative humidity? Well, perspiration is water. If you have, let's say, 50% humidity, you have plenty of room for that water to go, okay, as it evaporates. So it'll evaporate at a certain rate. Now, as the relative humidity goes up, not as much water can go in, so it goes in slower. Okay, so it doesn't evaporate as quickly, and you don't cool yourself down as quickly. So the heat index takes that into consideration and says, let's say it's 80 degrees, and it's, by the way, it only works for temperatures greater than 80 degrees. You don't have a heat index. Like right now, we don't have a heat index because it's 70, whatever it is right now, 74. Okay, so greater than 80 degrees. If your humidity is 80%, it's going to feel, okay, like maybe it's 85 degrees because your body's capability of cooling itself is about what it would be at 50% at 85 degrees. And that's the benchmark is 77 degrees and 50% humidity. So it's the same amount of moisture content in the air as you would get at 77 degrees and 50% humidity. I know that sounds convoluted, but just think of it this way. As it heats up, the air can hold more water, okay? But if you're up already almost saturated, it can't hold as much, and so it doesn't evaporate as quickly. Now, certain factors enter into the heat index. So let's say you have a heat index of 106, but if the wind's blowing, pretty much negates that. Because as the wind blows, it helps that evaporation and cools it down, so perhaps it'll only be 100 degrees. So that's the problem with some of these numbers. It gives you a good starting point and say, okay, if the heat index is 106 degrees, maybe I shouldn't go out and mow the lawn.
Right.
Maybe I need to hydrate a little bit better.
Or do it early or later.
Right. So that's what you use those heat indexes for, is not to say, oh gosh, it's 106 degrees. You just keep bear in mind that each person is different. You may have noticed, I have a little bit more body fat than you do. So I'm gonna stay warmer, and so the heat index is going to affect me a little bit more than it may affect you. Okay. So things like that. So that's basically it.
Well, and speaking of all the heat, we're going to talk about how air conditioning works in the 7 o'clock hour.
That's correct.
All right, Jesse, thanks. We have more of the morning show coming up next.